Hello children, today we are going to start a new series of exponents with this funny note. Have you ever noticed your unread WhatsApp messages double every time you blink? That is not your friend extra, that is exponential growth. Or only a tiny spark can start a wildfire or a viral video. So both are powered by the same formula. So we are going to study that today. Now that formula is y is equal to ab to the power x. I would suggest you to take a paper and pen set and start writing side by side. So our formula is y is equal to ab to the power x. This is what our formula is. But from where it has come? First, let's relate it with the linear formula. Linear formula is y is equal to mx plus b, where b is the initial value, right? And m is the slope. Slope, when I say slope, I mean rate of change, right? And this y is finally the output. And this x is the input, right? This is what you have learned. Now when it comes to exponential formula, it's like y is equal to ab to the power x. Here b is the rate of change. B is the rate of change, right? Y is output, as usual, output, and x is input once again. And here initial value is a, initial value, right? Actually, what is the meaning of initial value? Initial value means that when input is 0, that means you have just started your work, right? Whatever that work is. Now, let's explore this formula a little bit more. Let's come to the next level. In case of linear functions, when slope is positive, like it's increasing function, and when slope is negative, it's a decreasing function. Similarly, in exponential growth, we define b, or the rate of change, with two different situations. It can be growth or it can be decay. So that is the linear one, that is the exponential one. We are going to explore these two words, growth and decay, first. Let's come to growth first. Growth. Now I will not write the formula like y is equal to ab to the power x. I'll reach here with the help of example. Now suppose you deposit some money into the bank, that is your savings. Good amount, $1,000 in your bank as savings, and the bank says, oh okay, let's you invest your money in stocks, right? $1,000 you invested, and approximately, like if you say the average return is 10%. Now when this situation comes, it's 10, this 10% is not fixed, right? It will change every next time depending upon how much money you have in your mutual funds or shares or stocks. Now that is the initial value. That means you have just started your work, right? So here in this case, that is 1,000. Now after 1 year, right? After 1 year, first year is completed, and 10% of 1,000 is your profit, which is 100. So that means you have gained $100. That is your profit. And after 1 year, you have $1,100, right? But here's a catch. This 10% is not fixed. If it is 100 every times, it will be linear. It's not 100. This 10% is on the amount right now you have in your bank account, right? So 10% of 1100, and that is 110. So that means after second year, $110 will be, you will have 110 more dollars in your account. That is 1210. Now again, after third year, that 10% will be of 1210, which is $121, right? So this is 121. This time it's 1331. So you can see every time it's increasing, right? This 10% is increasing because the money is increasing, and the 10% is on the accumulated amount, not the initial amount. That is the catch here. Now, if I just want to calculate that after 10 years, how much money I will have, right? So I cannot keep on doing like this. So that will be, there should be a formula. So formula is, now I am breaking this B. Formula is equal to A 1 plus R percent raised to the power time. Sometimes we write this formula like this. This is R, right? So Y is equal to 1000, which is the initial amount in the beginning. Now you may get confused that in the second year, initial amount is 1100. No, no. Initial amount is always the amount when the input is 0 or you have just started whatever the process is. And this is 1 plus 10% raised to the power time. Y is equal to 1000, 1 plus decimal 1 raised to the power t. Y is equal to, have I done it right? Yes. 1000, 1.1 raised to the power t. Now I can say A is 1000, B is 1.1, right? And t here is the input, which is x in your formula. So here, according to the situation, input is time. That means for how much time you want to you want your money to be invested in mutual funds or stocks or shares, whatever is that. Here we have to observe something special. What is that? I am adding something to 1. Now, whatever the small number that is, it's always going to be greater than 1. Keep this point in mind. We will come to this particular step one more time. Now, let's talk about decay. Right, let's talk about decay. Decay is like, suppose you have a radioactive material, right? And every time or every year it decays, let's say 10%. Okay, that is a very, not a very good situation, but we have to understand, and these numbers are going to, give us the ability to concentrate on the concept more. So let's say it's 10%. Now, initially it is 1000 grams. Now it is decreasing, right? 1000 grams. Okay, fine. So that is the initial value. Here also, if I say AB to the power x, initial value is same. But here it is grams, or in case of growth, it's about the money invested in mutual funds or stocks or shares. Now, it is the initial stage. We have just started your experiment. After first year, let's say year, after first year, 10% of 1000 will decay, right? So that means decay is like 100 grams and you are left with 900 grams. Next time, that decay will be 10% of 900, right? So that means, which is 90. So that you will subtract 90, right? And which is 810. Perfect. So this is after second year. Again, let's do it for the third year. After third year, that will be 10% of 810, which is 81. So that will be 81, 9, 2, 7, 729 after grams after third year. Here it is decreasing. So it's decay. And if it is decreasing, our formula is going to be YA1 minus R upon 100 raised to power time. In case of growth, it's plus. In case of decay, it's minus. So Y is equal to 1000, right? 1 minus, now it's 10%. So 10% raised to the power time. That means Y is equal to 1000. 1 minus 0.1 raised to the power t, which is Y is equal to 1000, 0.9 raised to the power t. Now stop for a while, see the whole situation one more time, and try to figure out what is the main point here. Main point here is that because we are subtracting something from 1, this value is less than 1. And because we are adding something to 1, this value is greater than 1. So if I just come up with my actual formula, y is equal to abx. This is what you see in your books or everywhere. This b value, if it is greater than 1, the situation is a growth situation. And if this b value is less than 1, that is a decay situation, right? So if for example, okay, let's take an example. Suppose it's given, some situation is given 1000, and this is 1.3 raised to power time, right? So that means because it's 1.3 is greater than 1, so it's kind of growth situation. Or y is equal to 1000, let's say 0.8 raised to the power t. That means we are talking about some decay situation, right? Okay, so that means this is the basic concept behind exponential growth and decay, and this is how you explain every data in the situation. And now you know when it is growth and when it is decay. So from now onwards, we are not going to write this complete formula like 1 plus r over 100 or 1 minus r over 100. We have understood the concept. We will just see according to the b value. Okay, so just revise the whole thing, and let's meet in the next class for the growth model, where we will take only one situation and solve every possible SAT question in that. One situation, many questions. Let's meet in next class. Till then, goodbye.